All right, we're about to start section 13.2, which is measures of dispersion. So what is this all about? Well, let's go back a section to 13.1, which was measures of central tendency, in other words, averages. We were able to find averages in the previous section. So if I told you that my mean, median, or mode test score was a 75, you know that the middle, so to say, the average, so to say, is a 75, but that tells you nothing about how the students actually did. What if half my students got 100% and half my students got a 50%? Then my mean would be a 75, but no one actually scored a 75 and no one was near a 75. What if every single one of my scores was a 75? Then the mean, median, and mode would again be a 75 and everyone got that. So the question becomes, if we know the middle, how's the rest of the data dispersed or spread out about that middle? Is all the data really close to the middle or really far from the middle or somewhere in between? And that's called dispersion. So when we're talking about measures of dispersion, we're talking about where is the data relative to the middle, quote unquote middle, being the mean, median, or mode. So we're going to use three different forms of measurement to measure the dispersion of the data. The first is called the range. The second is the most important, called the standard deviation. And the third, which we're rarely going to use, is called the variance in this class. Now, if you're going on to a statistics class after this, you're going to see a lot more in-depth analysis of this. This is very much so just a topical thing. We're going to do a few things by hand, and then we're going to use our calculators to verify on a lot of these, which will be nice. Okay. So the first and the easiest is the range. So it says in the previous section we introduced three types of average values for a data set: the mean, the median, and the mode. Some characteristics of a set of data may not be evident from an examination of averages. For instance, consider a soft drink dispensing machine that should dispense 8 ounces of your selection into a cup. So imagine you have an 8-ounce coffee cup, okay? So 8 ounces is 1 cup. So what do you want? You want that coffee machine to give you 8 ounces of coffee. Okay, if you get less than that, you feel shorted, and if you get more than that, it overflows. So you need the accuracy of this drink machine. So let's look at machine 1. These are in the ounces that it poured. There's 9.52, 6.41, 10.07, 5.85, and 8.15. Notice they have the X bar notation. Remember that X bar means the mean of that data is 8. So you could add them all together, divide them by the number that there are. There's 5 of them, and you would get a mean of 8. Let's look at machine 2. It's 8.01, 7.99, 7.95, 8.03, and 8.02. If we added all that data together and divided by 5, we would also get a mean of 8. So both of these machines have the same quote-unquote average. They have the same mean value. On average, it says they both dispense about 8 ounces of liquid. But is that really the story? If you were to own these two machines, which of these two machines do you want? And I think it's pretty evident just by looking at the data value that machine 2, almost every pour is really, really close to that 8 ounces. It's dialed in, it's really accurate. So everything is really close to the mean. And when everything's really close to the mean, that means it has a low measure of dispersion. If everything's close, it's a low measure of dispersion. Okay? Look at machine 1. It's all over the place. It has some that are way higher and some that are way lower. That is high dispersion. Thing is spread out far from the mean. So high dispersion on that one. Okay? So it says the mean data value for each machine is 8 ounces. However, look at the variation in the data for the machine 1. The quantity of soda dispensed is very inconsistent. In some cases, the soda overflows the cup, and in other cases, too little soda is dispensed. The machine obviously needs adjustment. Machine 2, on the other hand, is working just fine. The quantity dispensed is very consistent with little variation. It says this example shows that average values do not reflect the spread or dispersion of the data. To measure the spread or dispersion of the data, we introduce statistical values known as the range and the standard deviation. So those are the two primary ones that we're going to be doing. Again, it's range, and the second one is the standard deviation. So what is range? Range is exactly what you guys think it is. So it says the range of a set of data values is the difference between the greatest value, data value, and the least. So essentially what the range is is the high value minus the low value. How much spread is there between the highest value and the low value? So range is one measure of dispersion, but likewise in the previous section we said mean is a horrible measure if you have outliers. Well, I would say the exact same thing with the range. The range is a horrible measure if you have outliers. So if we had a test score of 0 and every other student scored from 75 to 100, the range would be 100 because it would be the top score minus the low score, so 100 minus 0 is 100. The range would be 100, which would kind of give us the idea that there's scores all over the place. And in actuality, the real range is score values between 75 and 100, which only has a range of 25. So if you have outliers, the range is a really bad measure. But if you have data that's close together, range can be a nice measure of dispersion. We won't use range too much, but that's what it is. Okay. So it says, example 1, find the range of the numbers of ounces dispensed by machine 1. So if we look at machine 1, what we need to determine is which one's the high. So if I'm looking here, it looks like the 10.07 is the high value. And I also need to know the low value, and that's about 5.85 is what I'm seeing as the low value. So I'm going to come in here into my paper, and I'm going to write those down. Again, the high minus the low. Minus the low. And in this case, we had 10.07 minus 5.85. Throw that in your calculator, and I'm getting a range of 4.22, and that's in terms of ounces. So let's talk about what it is. So the range from the high to the low is 4.22 ounces. Now remember, this was supposed to be an 8-ounce cup, so we're saying the range is like half of the cup. That's a lot. That's a huge, huge range.